In 1931, two men named Max Knoll and Ernst Ruska created the first magnified images of mesh grids utilizing the first ever electron microscope. This was done at the Technical University of Berlin. The microscope works by focusing a beam of electrons by utilizing electromagnetic lenses to focus the electrons instead of light to make an extremely magnified image of tiny objects. At first, when the microscope was invented, it could only magnify up to 400 times, but now, with some slight human technological advancement, we can now achieve up to 50 million times magnification, which is quite the advancement, being able to literally observe atoms. The reason why electron microscopes are so much better than optical microscopes is that electrons have a way smaller wavelength, approximately 100,000 times smaller than visible light, therefore creating higher resolution images using these microscopes. There are two types of electron microscopes, that being transmission electron microscopes, aka TEM, which can view very extremely thin slices of objects at the atomic level. And also there is scanning electron microscopes, SEM, which creates detailed 3D images of surfaces. However, electron microscopes are also used in a field of study called condensed matter physics. These microscopes help us understand how the atomic structure works, as it can zoom down to the atomic level, and we can observe crystal structures and find defects. As condensed matter physics evolves and our understanding widens, we can see it continue to improve in these fields, that being energy storage, medical technology, and quantum computing. Condensed matter physics can also be used to help us create new materials such as semiconductors, superconductors, and graphene, which is a quantum material. CMP, aka condensed matter physics, but it's just shortened, is also a contributor to the main development of microchips, transistors, and nanomaterials, which lead us to our next topic. Nanotechnology is thoroughly linked with condensed matter physics due to its development of microchips, transistors, and condensed matter physics also provides a fundamental understanding of how, hence again, materials function at the atomic and nanoscale. In 1959, Richard Feynman introduced the concept of nanotechnology at his lecture. This lecture laid the foundation for manipulating materials and matter at the atomic level. Nanotechnology to this day is extremely useful. Despite it being a developing material, it is currently being used in fields of medicine, helping for diagnosis and delivering treatment, and also for energy, making it more efficient for either fuel combustion or more efficient solar cells. In conclusion, as we evolve as humanity, technology will always continue to improve our understanding of science, as proven by the electron microscope being able to make us understand condensed matter physics and nanotechnology. Then, nanotechnology would continue a new cycle, with nanotechnology being able to potentially make even better microscopes, repeating the cycle all over again.